We're continuing with section 16.3 and properties of conservative vector fields. And the first thing is if C is a closed curve, that is the two endpoints P is equal to Q, and then the vector line integral f dot dr over the path is equal to 0. And so look at the this is the picture on the left, the cyan picture. This is the path. You start from one point and come back to it. And so remember, the fundamental theorem says if the field is conservative, then there is a potential function. And so what you do is you evaluate the vector line integral by plugging in the endpoints and subtracting in the scalar potential, which is sort of an antiderivative of f. And so in here, when P and Q are the same, this is going to be 0. The next thing is that now that I know this, look, the purple color paths look like they're going around in a circle too, but realize that P is on this side, Q is on this side. And then you have R going from P to Q, and also you have R1 going from P to Q, and R2 going from P to Q. And then the second thing that comes in mind is this for these properties. Let's say if I had instead of, so this is C1 and this is C2. If instead of going C2 was the negative direction of C2, was going from P to Q, then I would have C1 and then coming back here to negative C2. So then C1 and negative C2 would make you the C1 and union negative C2 FDR would be 0. Why? Because then C1 and negative C2 together would make a loop, make a closed curve. And so from here, I can rewrite this as f dr over C1 minus f dr over C2 is equal to 0. Or we can write f dot dr over C1 is equal to f dot dr over C2. This is the second consequence. We use both of them a lot, especially this one. This is basically saying that the conservative vector fields are path independent. And so line integral only depends on the endpoint, not the path of the integration when you're trying to do the vector line integrals. So let's do an iClicker and then do an example for this section, for this part. So suppose that F is a conservative vector field. The contour map of a scalar potential of F is shown in red in the figure on the left. Evaluate f dot dr over the path C. So let's pause and come back to it. Okay, now that you pause, notice that f dot dr is going to be the potential F at the endpoint, whatever that is. Let's say P, and then let's say Q. Starts from point P, and so it's going to be F at Q minus F at P. What is F at Q? F at Q, we have the F, the contour map of F, and I see it's 50. And then what is F at P? It's 10. What the contour map again? 40 is the answer. Okay. So now let's do an example. Suppose f is equal to gradient of f, where f of x and y and z is equal to -1 over x squared plus y squared plus z squared. Find the work done by f in moving an object along a smooth curve from 1 0 0 2 0 0 2 without passing through the origin. So what is the formula for the work done? That is over the curve C, it's again F dot dr. Okay, and so I don't know what, and I can calculate it, the vector field F, by taking the derivative with respect to x, y, and z and finding the gradient vector. Or I can rely back on the fundamental theorem of conservative fields. And so in that case, I have to plug in the endpoint. Let's say this is P, the beginning point, that's Q. So I have to plug in F of Q minus F of P. Okay, so one thing that you notice is that it tells you without passing through origin, because when you pass through origin, there will be a point of discontinuity for the gradient vector and for the potential function, and therefore for the gradient of that also. And so in here, if I plug this in, Q in there is going to be -1 over 0 to power 2 plus 0 to power 2 plus 2 to power 2, and in there I get 1 over 1 to power 2 plus 0 to power 2 plus 0 to power 2. So this is going to be -1/4 plus 1, which is 3/4. Well, this is much easier than taking the line integral, basically, and that's what you want to do if you have a conservative vector field. Again, none of this is going to work if the vector field is not conservative. The fundamental theorem of conservative vector field only works when the field is conservative.